Hey everyone, and welcome to this new lecture in the series in grade 11th math. In this lecture we will start a new topic, and that is probability. We finished complex numbers before, and then we went on to talk about coordinate geometry. In that we talked about recently about three-dimensional geometry and two-dimensional geometry and conic sections. So now we will be beginning with this new topic, probability. In this lecture we'll only talk about the introduction to probability, that is what probability is, how it relates to the real world, and just a basic intro on probability, nothing too complex. The aim over here is to introduce the common concepts in probability. After this we'll be going towards combinations and permutations, which of course you don't have to worry about right now. We'll get to that after we're done with this lecture. So what is probability? As you can see from the word itself, it talks about the idea, the chance of something being probable, like how probable it is that something would happen, and how probable it is that something from these two options would happen. How probable it is that one team is going to win the match if it rains or if the pitch is like that. So that is when you're using probability in your real life. So in this we're just going to put a mathematical effect to it, how probability really works according to math, and we're going to talk about that. So just like I said, you don't have to memorize this definition. Probability is a measure of how likely an event or outcome is. Different events have different probabilities. Conversely, it is also true that probability is a measure of how unlikely an event is going to be, how probable it is that this thing will not happen. That is also probability. This is how you use probability in your real life. Over here we're just giving it a definition. So these are the terms that you use generally in your real life to talk about probability. Once you know that you're going to get something done, you say certainly it's going to happen. It's highly likely if you know that there is a chance, like 1% or 2% chance that something might not happen. And if you reverse that, it becomes unlikely that there is a chance that something might not happen. Just like in likely there was a chance something might happen. Moving on, then there's something known as impossible. Like it's impossible that you can prove that 2 plus 2 is equal to 5. It's impossible that you take a box, you put 2 balls, and you put more balls, and you're going to have 5 balls. Of course, that's not going to happen. That's the probability of that is 0. There's 0 chance that it's going to happen. So we usually express probability in terms of fractions. The numerator basically represents the chance, the probability that this particular thing might happen, and the denominator basically represents of all the chances that might take place. I'll explain to you with the help of an example. Let's take this bag. So this bag basically has 3 red marbles, 2 white marbles, 1 purple marble, and 4 green marbles. So if you add all of these, you're gonna get all together of 10 marbles. Now if I ask you what is how probable it is, or what is the probability that you're going to get a certain number of marbles when you put your hand in the bag to take out a marble. For example, if I ask you what is the probability of you choosing a red marble, if you don't look inside the bag and you put your hand in and you take out a marble, what is the probability that you're going to get a red marble? So the probability of that is going to be 3 by 10. Now just like I explained to you, 3 is 10. First of all, let's just look at 10. 10 is the denominator over here. The denominator basically represents all the possible values that can occur. That is, there are altogether 10 marbles, so you can, amongst those 10 marbles, you can choose 3 red or 1 purple or 2 white or 4 green. So the denominator is going to represent the total amount, that is, like we talked about over here, the denominator is the total number of possible events that could occur. So the total number of possible events in this case is going to be 10 marbles. Of course, it's going to be 10 because there are 10 marbles, and the total number of the probability that 3 of them that red marbles could be chosen is going to be 3. So that is how we explain probability. Now in this slide, what I want you to concentrate is the last line of this slide. So you see, the first point over here is that the probability assigned to each outcome is non-negative. Of course, this is just basic common sense, but you have to remember the sum of all probabilities equals 1. Now if we go towards the example that we just went through, what does it mean that the sum of all probabilities is going to be equal to 1? Okay, if the all probabilities over here are going to be, what is the probability of the red marbles? That was 3 by 10. The probability of white marbles, that is 2 by 10. The probability of purple marbles, that is going to be 1 by 10. And the probability of green marbles, that is going to be 4 by 10. Now the thing with this is that if you convert it into decimals, or even if you just add this 3 by 10, 2 by 10, 1 by 10, or 4 by 10, the answer has to be 1. Of course, which it would be. The answer would be 1, because if you add all of these, the answer is going to be 1. The probability is equal, the sum of all probabilities equals 1. By all probabilities, it means that what is the chance that something might happen, and what is also the chance that something might not happen. For example, what is the probability over here that you would not get a red marble? What is the probability that you won't get a red marble if you choose out a marble randomly? Now you know that there are 3 red marbles, and there's 7 marbles in the bag that are not going to be red. So the probability of not getting a red marble is going to be 7 by 10. So if we divide the question into two parts, that is A, what is the probability of getting a red marble, and B, what is the probability of not getting a red marble. So the sum of these probabilities is going to be 1, and that is what it is, 3 by 10 plus 7 by 10, 0.3 plus 0.7. So just remember this, and of course you can just go through all of this. What is the sample space? Sample space is the the total number of possibilities that can occur, and then there is an outcome, that is the possibilities. So of course probabilities and the assignment of probabilities related with each outcome. So you see, this was just to explain to you the how we describe this question. Let's look at it this way in this slide. So you see, sample space is nothing but the total number of possible outcomes. So if we have another example, let's just say we have a dice. So we know that there are altogether 6 different digits on a dice. So the sample space is going to contain all the possible outcomes, that are 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 is going to become the sample space, and the probability of a particular event is going to be the number of ways that that event can occur. That's going to go in the numerator, and the total number of possibilities, that is going to go in the denominator. So the probability that any particular event is going to occur, we're going to discuss this through this formula over here. Now let's take an example. What is the probability that you roll the dice and you get an even number? How many even numbers are there on the dice? We have 2, we have 4, we have 6. So the number of even numbers that we have is 3. The total number of numbers that we have is 6. So the answer is going to be, the probability of getting an even number that you roll the dice is going to be 3 by 6. This is the same as the probability of the odd number. The probability of getting an odd number is going to be 3 by 6 once again. Why? Because there are 3 odd numbers, 1, 3 and 5. So this is how you get try to find the probability of a particular dice. Remember, number of total possibilities is going to be the denominator, and the possibility that you are looking for, that what is the probability of that particular possibility, that is going to be in the numerator. Now since till now we have been talking about possibilities, we have been talking about events. Now there are different scenarios in which events are independent from each other. For example, if it rained on Tuesday, my chair broke at work. Now these are not related events. It's not necessary that just because it rained on Tuesday your chair broke. Just like that, there are independent events and there are dependent events. Right now we'll be talking about independent events. For example, if you get an even number on the first dice, on the first throw of the dice, it's not necessary that you're going to get an even number in the second roll of the dice. Or it's not necessary that you're going to get an odd number in the second roll of dice. So these are basically independent events. That is, that one event, the outcome of one event does not have any effect on any other event. Now let's just say event A, today it will rain in Delhi. Event B, today I will reach office late. C, possibility of both events A and B happening together. So now if the probability of A is 0.1, that is over here, that is today it might rain in Delhi, and the probability that you might be late at office is 0.02, that is very less. Now if you would find out that the probability that both of these events are going to happen, that although these events are independent, what is the chance, what is the probability that both of these might just happen? So in order to find that, we do this, we basically multiply the probabilities, and that is probability of A being multiplied by probability of B, and we're going to get 0.002. That is, it is highly unlikely. It is unlikely that it might rain and you might reach office late. So this is how we find out the different probability. If we have two different probabilities and we want to find out what will happen if we want to get if you want to see if what if both of these happen. Now this type of probability is called the conditional probability. We already talked about the independent probability. So the conditional probability of an event A is the probability that an event A will occur given that another B has occurred. That is, it has a condition that A will only happen if B has occurred. So this probability has a condition in it. So since it has a condition in it, this is called conditional probability. This is how we represent it. And forget about the formula on the top. You don't have to remember them. You don't have to memorize it. This is just to show you how it will look in the set theory, because you have this event A, you have this event B, then there's an intersection of these events. So you can visualize this through this. Now of course we have to explain this by the help of an example. So this example basically is a pretty easy example. It will help you understand how probability of different two events that might be connected takes place. So if you have two dice, one red in color while the other is green, the probability that the sum of numbers on the dice is 9 is going to be 4 by 36. Now the reason for that is because there are 4 altogether combinations that will give you the sum of 9 if you roll the dice. One is going to be 3, 6, 4, 5, 5, 4 and 6, 3. This is how different combinations that you're going to get red and green of red and green dice. After you have these combinations, you're going to get the answer, that is, you're going to get the sum 9. Now what if you've rolled both the dice and you have seen that the red die has shown 5. Now but you haven't seen the green die. Now what is the probability? How would you get the answer 9 if you haven't seen the green die? What should be there on the green die that should give the answer of 9? Of course we know that if the green die would have 4 on it, then only we will get the sum of the two dice to be 9. Now what would be the probability that you're gonna get 4 on the next die? Now this is really simple, really easy to understand. Just try to visualize what would be the probability that you're gonna get 4 in the green die. The probability they're gonna get 4 is 1 by 6. Why is that? Because there are 6 possibilities, and since there are 6 possibilities, and 4 is just one of the possibilities, so the probability is going to be 1 by 6. Now let's move on to another third concept, and this is the complementary events. The complementary events are basically one event is the complement of another event if the two events do not contain any of the same outcomes. Basically what this means is that, like we talked about in the example of the marbles, that what is the probability of getting a red marble? That was 3 by 10. The complement of that is going to be 7 by 10. The probability of not getting a red marble. So that is what the complementary events are. Basically they complement the events that we talked about. This is how it is written. E, that is, this is read as E complement, and if this is basically, we already talked about that the probability is going to be 1, so the complementary is going to be 1 minus the probability of that that particular event. That is, in the case of the red marbles, is going to be 1 minus 3 by 10. So this is pretty much it for probability. We talked about independent events, complementary probability, conditional probability, and we talked about general probability in general. Furthermore, we're going to talk about combinations and permutations in the next lectures. So hopefully I'll see you then.